Hi, Mr. Green here. I'm going to take you through the next section of the energy topic of the Physics GCSE. This lesson concerns heating and insulation, and the learning objective is to learn how insulating homes reduces heat loss. Pause the video and write that down as your title. Okay, we'll start as we always start with some retrieval questions. If you could pause the video, answer those questions and restart when you would like the answers. Okay, question 1. How does energy transfer in a metal? The ions in the metal vibrate and pass the energy on as vibrations. In addition to that, free electrons that are able to move through the structure carry the energy along the structure as well, increasing the amount of conduction that takes place. Why are metals good conductors? It's because these free electrons can carry the energy really quickly through the structure. If an atom doesn't have that, if it's a non-metal, it doesn't have free electrons, it's not as good at conducting that heat. Question 3. What material would you expect a kettle handle to be made out of and why? You'd expect it to be wood or plastic because they are poor conductors. They are what we call insulators. So it wouldn't heat up or wouldn't cause you any sort of harm when you were to touch it. Why are metal benches cold but wooden ones warm? It's because metals are such good conductors, so they can transfer the heat away from our bodies efficiently, whereas wood's an insulator, and so it doesn't transfer that energy efficiently at all. And question 5. How can we reduce unwanted heat losses? We can reduce heat transfer by the 3 methods of conduction, convection and radiation, and this can be done by using specific materials and certain colours. We're going to look at that in a bit of detail now. Our learning outcomes today are to describe how you can reduce the rate of energy transfer in your home. First off, if you could draw a house, has to be a diagram, not exactly like that, but identify all the ways in which heat can escape from the house. Pause the video whilst you attempt that. Okay, so here's the ways it can all escape. First off, it can escape through the roof, heat can escape through the walls, heat can escape through the floor, heat can escape through the windows, and heat can escape through gaps around the doors. If we want to try and reduce heat being lost by houses and try and stop us wasting that heat, we need to attempt to stop these things happening. So the picture below shows some of the measures that can be used to reduce the rate of energy transfer from your home, and so it reduces your home heating bills. We've got there loft insulation you can place in your roof, which will stop heat travelling through there. We can use draft excluders around doors, which will stop energy being transferred that way. Through the windows we can fit double glazing and curtains, which again will reduce the energy transferred through there. In the walls we can fit something called cavity wall insulation, and that insulation will stop heat transfer through there. And through the floor we can fit carpet, and that carpet reduces the energy loss. Okay, for our next method we're going to fill in this table, so if you could pause the video and copy that table down, I'll go through some slides that go through each section of these to tell you how they stop heat transferring and why they do that. So pause the video whilst you copy that table down. Okay, so first off, loft insulation. We can use loft insulation like fiberglass, and that reduces the rate of energy transfer through the roof. Fiberglass is a really good insulator, and it also traps air between the fibres, so that reduces energy transfer by conduction and convection. Conduction is where it will travel straight through the material. Fiberglass being a good insulator means it doesn't travel through it, and trapping the air means the air can't move around, and so it stops convection currents from flowing through there. The greater the number of layers, the thicker the insulation will be, so the rate of energy transfer will be less. So the more that you have, the less energy transfers through there. As you can see from the diagrams, if you insulate your loft, the heat is reflected back into the house, where if it's uninsulated, heat continues and travels through there. Cavity wall insulation, it reduces the rate of energy transfer through the outer walls of the house. So the cavity of an outer wall is the space between the 2 layers of brick that make up the wall. If we pump an insulator into that cavity, number 1, it stops conduction. It stops energy travelling through the brick of the wall through to the next part of the wall. So it stops conduction that way. It also traps air, so if we put some foam in there, that will trap air, and that will really reduce convection taking place in there. Because again, air cannot move around and we can't set up convection currents in that way. So in the gap between the walls, we put a foam in there. This stops both conduction and convection because it's a poor conductor, and it also stops the air from moving, stopping convection currents setting up. We can place aluminium foil between a radiator panel and a wall. The silver of the aluminium foil is a really good reflector of infrared radiation. So it reflects that infrared radiation back into the home, heating it up more. So it reduces the rate of energy transfer by radiation through the walls because it reflects that back into the house. Double glazed windows. They have two glass panes with either dry air or a vacuum between the panes. The thicker the glass, the lower its thermal conductivity is, and so the slower the rate of energy through conduction. So it won't conduct the heat through there if it's a really thick glass. Dry air is a really good insulator, so it also stops conduction taking place there. But the vacuum would be better because again, you've got no air particles there, so it can't set up convection currents, so it stops energy transfer via convection too. If the external walls of a warm building have thicker bricks and lower thermal conductivity, the rate of energy transfer from the inside to the outside will be a lot lower. So we need to look at the materials and the size of the bricks we're making it from. Again, by using it this way, we are stopping conduction taking place. If it stops conduction taking place, we will stop energy being lost through the walls of the house, and so our heating bills will be lower. There's the table. Pause that if you want to check your answers, or green pen it and make sure that you've got the correct answers there. Pause the video to take those down and restart it when you'd like us to continue. Okay, so we've got 5 different methods of insulation there. We've got a single wall, we've got double glazing, we've got cavity wall insulation filled with foam, we have a cavity wall, and we have single glazed. Put those in order of most insulating to least insulating. Pause the video whilst you do that. Okay, there's the order. The best insulator would be the cavity wall insulation with the foam inside, and the worst insulator would be the single pane of glass. Underneath each one, you'll see there we have a figure that's heat transfer in watts per meter squared. So how much energy is transferred per second through that per meter squared of the material. The lower that value is, the better an insulator it is. We refer to these as U values. So the lower the U value, the better an insulator it is. Whereas the higher the U value, the worse an insulator it is, and it will conduct heat through it. We can see the cavity wall insulation only lets through 0.5 watts per meter squared. So every second, only half a joule per meter squared will be placed through there. Whereas on the single pane of glass, 5.7 watts per meter squared, that's nearly 6 joules per second per meter squared going through there. Much worse. So a wall with a high U value will transfer more heat, so the room would lose heat energy quicker and it would cool really quickly. Explain how the double cavity insulated wall keeps a room warm and why do we want it to have a low U value. As well as that, if you could compare and contrast double glazing against single glazed windows for home insulation, and in your answer could you include the U values. Please pause the video whilst you attempt those 2 questions. Okay, so for the double cavity insulated wall, what we have is double cavity insulated walls reduce heat transfer by conduction and convection. Conduction, the gap between the walls, means vibrations in one wall can't be passed to the other, and convection, the material in the gap contains trapped air which can't move and allow convection to take place. The U values state how much energy is transferred per second per square metre of the material, and a low U value means smaller amounts of energy are transferred per second per square metre, keeping that thermal energy inside. When we're comparing and contrasting double glazing against single glazed windows, remember we need to include our U values. So double glazing has a U value of 2.7 watts per metre squared, whereas single glazing has got a U value of 5.7 watts per metre squared. This means double glazing more than halves the energy lost through the windows. So double glazing is a much better insulator. It'd be much better for the house. However, double glazing is much more expensive than single glazing. However, this could be offset by the savings made in the heating costs for the house. So you'd save a lot of energy in heating costs by installing this double glazing. Okay, got some past paper questions for you to look at here. If you could pause the video and attempt these questions as they come along. Okay, so question 1. Many people use a sleeping bag when they sleep in a tent, and sleeping bags designed to keep a person warm have fibre fillings. Complete the sentence by choosing the correct words from the box. The fibre is designed to reduce heat transfer by conduction and convection. Why is the fibre good at reducing heat loss from a person sleeping in the bag? Mark scheme states this. It traps lots of air. We don't accept it traps heat. So if you've said it traps heat, we don't give you the mark. You have to state it traps lots of air. And air is a really good insulator. Or you could state air is a poor conductor. Attempt question 2 there. Please pause the video whilst you attempt it. Okay, so people do a number of things to reduce energy loss from their homes. Describe one thing they may do to cut down the energy loss through the roof. You can insulate it with fiberglass, foam, felt, polystyrene, rock wool or aluminium foil. Any of those, you need to state you insulate it, but you need to state what you'd insulate it with. The outside walls, you could fill the cavity between the walls with fiberglass or foam, polystyrene, or you could make the walls thicker. Any of those is an acceptable answer. The glass in the windows, we could make it double glazed, we could draw the curtains or the blinds, we could use thicker glass, or we could use any type of secondary glazing, so talking more double glazing. And the gaps around the front and back doors, we could use a draft excluder, we could use a strip, or we could fill the gaps in some way. We could have double glazed doors or even build a porch there, use curtains inside the door or place a mat under the door, anything that's going to fill those gaps in. Question B, a house is more difficult to keep warm in cold weather. What other type of weather makes it difficult to keep a house warm? Any of those will do. Windy, stormy, wet, snow, rain, sleet, hail, fog or mist. Any of those named would be an acceptable answer. Higher question here, so if you could pause the video and attempt this, it's slightly more difficult. Okay, so question states, the figure below shows a cool box, and the cool box is used to keep food colder than the surroundings. The cool box consists of plastic walls with a layer of polyurethane foam between them. The polyurethane foam has a low U value. Why does it need to have a low U value? We need the low U value so it is a good insulator. The polyurethane foam contains air bubbles. How do the air bubbles reduce energy transfer through the walls of the cool box? Refer to the process of energy transfer in your answer. What we need here is a statement that air is a really good insulator, so it reduces conduction. 2 marks for stating that. Your third mark is for saying that the trapped air cannot move, so that stops convection taking place through there. Final question. An ice pack can be placed inside the cool box, and the ice pack contains material with a very high specific heat capacity. The ice pack is frozen in a freezer and cooled to -18 before being put in the cool box. The ice pack keeps the contents of the cool box cooler than the surroundings for a long time. Describe how. Pause the video and attempt that question. Okay, so you need any 3 of these. You could say the ice pack is much colder than the cool box contents, so it reduces the overall temperature of the cool box. The ice pack requires a lot of energy to heat up or change its temperature. The ice pack requires heating up before the cool contents warm up. Or the ice pack cools the air, which becomes more dense and sinks. Again, you're allowed to say there the ice pack would cool and cause a convection current. Okay, hope that was useful for you all. There's plenty of videos available on our YouTube channel. I hope it was useful. See you again soon. Goodbye.